in class, we solved a problem involving numbers summing to 10. But what we didn't talk about was why it works. So remember the question, how many ways are there to add 1s and 2s to get to 10 where the order matters? And we solved it by starting small and looking for a pattern. The target was 1, there was 1 way, 2, 2 ways, 3, 3 ways, 4, 5 ways, 5, 8 ways, etc. And we'll call these were the Fibonacci numbers. We observed it, but did we prove it? No. When we did the lions and tigers problems, we developed an argument, a line of reasoning, a logical line of reasoning, why answers to those questions had to be correct. Here we just noticed a pattern and assumed or hoped or prayed or thought that it would continue until we got to a target of 10, but we didn't actually see why. So in this very short screencast, I want to try to convince you why that pattern is there. So recall that through systematic lists, we use tree diagrams, we found all the ways to reach 4 and 5. So if the target was 4, there were 5 ways. And instead of a tree diagram, I'm just making a systematic list here. And my first one is 2, 2. I don't have a plus sign because the plus signs just are distractors. But we see, oh yeah, that's going to be all the ways to get to 4. 2 plus 2, 2 plus 1 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2, 1 plus 1 plus 1 plus 1. And similarly, there were 8 ways to get to 5. So those we got just by making lists. Now suppose we believe in those two, why is it that there are going to be 13 ways to get to 6? Do we have to write them all out to be sure, or can we see why it has to be true based on these? Well, if you think about it, if your target is 6, then the last number in your sum was either a 2 or 1. If your last number was a 2, then the number of ways if your number was a 2, then the number of ways to get there would be one of these 4 sets, so one of these 5 ways of getting to 4 followed by a 2. And if your target was, and if your last number on your way to 6 was a 1, then it must have been one of these 8 ways followed by a 1. So we see that played out here. If your target's 6, you've got either one of the 5 red ones, one of the ways to get to 4, followed by a 2, or one of the 8 green ones, one of the 8 ways of getting to 5, followed by a 1. So of course, and that's going to be it. There's no other way to get to 6, because if your target is 6, you must have ended with a 1 or a 2. So that's why you add 2 to get the next one. And if we wanted a target of 7, then we could put a 1 after these 13, and a 2 after these 8, and that'll give us 21 ways of getting to 7. So I hope that makes sense as to why the method works. Thank you.